Have you ever wondered what would happen if a massive asteroid was heading toward Earth? Scientists have been brainstorming ways to protect our planet from such catastrophic events, and one of the most intriguing solutions involves using nuclear explosions to generate X-rays that can deflect asteroids. In recent years, the threat of asteroids has become more prominent in scientific discussions. With the advancement of technology, we now have the capability to detect potentially hazardous asteroids earlier than ever before. But detection is only the first step. The real challenge lies in deflecting these space rocks away from Earth. So, how exactly do scientists plan to use nuclear X-rays to achieve this? The concept is both fascinating and complex. When a nuclear device is detonated in space near an asteroid, it produces a burst of X-rays. These X-rays can then heat the surface of the asteroid to extremely high temperatures, causing the material to vaporize and create a jet-like force. This force can alter the asteroid's trajectory, pushing it off its collision course with Earth. One of the key advantages of using nuclear X-rays is their ability to deliver a significant amount of energy over a short period. This makes them highly effective in imparting the necessary momentum to the asteroid. Moreover, the method can be fine-tuned to target specific areas of the asteroid, ensuring a more precise deflection. Interestingly, this idea is not entirely new. The concept of using nuclear explosions to deflect asteroids has been around for decades, but recent advancements in our understanding of asteroid composition and behavior have made it a more viable option. Scientists have conducted numerous simulations and experiments to test the feasibility of this approach, and the results have been promising. For example, the Double Asteroid Redirection Test (DART) mission by NASA, which successfully altered the orbit of an asteroid by crashing a spacecraft into it, has provided valuable insights into how we can manipulate asteroid trajectories. Building on this knowledge, researchers are now exploring the use of nuclear X-rays as a more powerful and efficient method. One of the most fascinating aspects of this approach is the precision required. Scientists need to carefully calculate the distance at which the nuclear device should be detonated, the angle of impact, and the amount of energy needed to achieve the desired deflection. Even a slight miscalculation could result in the asteroid breaking apart or not being deflected enough. Moreover, there are significant safety and ethical considerations. The use of nuclear devices in space raises questions about the potential for unintended consequences, such as the creation of space debris or the risk of nuclear fallout. However, proponents argue that the potential benefits far outweigh the risks, especially when considering the devastating impact an asteroid collision could have on Earth. As we continue to explore the cosmos and discover new asteroids, the need for effective planetary defense strategies becomes increasingly urgent. The idea of using nuclear X-rays to deflect asteroids represents a bold and innovative approach that could one day save our planet from a catastrophic event. In conclusion, the use of nuclear X-rays to deflect asteroids is a testament to human ingenuity and our relentless pursuit of knowledge and safety. While there are still many challenges to overcome, the progress made so far is a promising step toward ensuring the long-term survival of our planet.